Water by Khalid Zaghloul. We drink water, we swim in it, we wash with it, and we chill things off with it. Since water is so normal, a considerable amount of us neglect to see exactly how peculiar it is contrasted with different substances. When we plop an ice cube or two into our beverage during the hotter months, we watch it glide over the fluid in our glass without the slightest hesitation. In any case, for what reason does ice do this? And all the more significantly, for what reason does water freeze from the top to the base when most other substances freeze from the base up? Well, water is a transparent, tasteless, odorless, and nearly colorless polar molecule. The unequal sharing of electrons within a water molecule makes the water molecule polar. The electrons spend more time with the oxygens of the water molecule than with the hydrogens of the water. Thus, the oxygen has a net negative charge and the hydrogens have a net positive charge. Water freezes starting from the top, which permits ice to glide due to an odd characteristic in how water's thickness carries on at falling temperatures. Thickness is the mass of a unit of volume of a material substance. It is basically a proportion of how firmly stuffed the particles are in the atom and in the substance. For most liquids, falling temperatures cause the compound's volume to diminish while its thickness increases, with the iotas and the particles turning out to be all the more firmly pressed together. For instance, a pocket of warm air rises and extends on the ground that is less thick than the cooler air around it. On the other hand, a pocket of cool air slips and agreements getting marginally thicker and denser as it falls. Water carries on comparably, yet just down to a specific temperature. The thickness of cooling water will increment until water's temperature arrives at 4 degrees Celsius, or 39.2 degrees Fahrenheit. In the event that the water keeps on cooling, its thickness will start to build once more, and water, presently in its strong state, will grow. It is this property of water that permits ice to wedge open breaks in walkways and shakes and make jars of containers of soda pop detonate in the cooler. At 4 degrees Celsius, water is still in its fluid structure. In lakes and streams, this water will cool at the surface, become denser, and plunge. As water moves towards its point of solidification, 0 degrees Celsius, otherwise known as 32 degrees Fahrenheit, it will turn out to be less thick than the water around it, and it will ascend to the highest point of the water segment. On the off chance that water rather solidified from the base of the lake or stream to the top, there would be significant biological results. In bigger lakes, a story of ice and slush would cool the water above, perhaps easing back the digestion and development pace of creatures that may do in the lake's fluid upper spans. Under these conditions, Earth would look totally different. The planet's polar districts would be about without life, and consistently mid-latitude plants, creatures, and different living beings would confront the possibility of hopeless fluid water and ice cold all the way through living spaces. Thank you for watching, and I hope you enjoyed.